Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. We are now in the second video of a three-part segment on doing additional pre-processing on your data. So this is related to data cleaning, right? We just cleaned our unreadable variable names. Now we're going to combine multiple years of data and then attach identifying information that you may have received from your State Department of Health if you have a contract with them. So let's go back to the R console where we just left off. All right, so actually, if I had my way and I could kind of pick my optimal workflow for working with BRFSS, what I would want to do is first filter out the states equal to 6 and then what I would want to do is first filter out the state equal to 6, then attach all of the data files, and then clean the variable names. But as we saw in the last video, you can't filter out the variable names that are surrounded in quotes because R just doesn't like that. So we had to clean our variable names first. Now we have to filter out for the state equals, we're interested in California, so state equals 6. And the reason why we're looking at just the state level is because if you are working with identifying information that you receive from your Department of Health, you only have access to that single state, right? Or if you're working across multiple states and you have multiple identifying information, you can attach those files to your BRFSS file. But you wouldn't have access to identifying information across the whole country, right? So we're just filtering it out by one state so that it's more applicable and realistic to something that you might be dealing with. So let's start by taking these data files, which we just made in the last video. So LLCP 2015X is the LLCP 2015 data file that also has the variable names, which we just cleaned to begin with an X. All right, so pipe that into a filter where we set the X underscore state variable equal to 6. So X underscore state equals 6. We're doing that for 2015, 2016, and 2017. We'll rename those objects California 2015, California 2016, and California 2017. So let's read those in. Let's take a glimpse. Glimpse California 2015. All right, so in 2015, there were 12,601 observations, and there are 406 variables. So that's the original number of variables from the LLCP 2015 dataset, plus the X underscore variables. All right, so 406. Let's glimpse 2016. So we had 11,393 observations and 432 variables. Again, that includes the original variables plus the X underscore variables. And then glimpse 2017. Yep, 9,358 observations and 440 variables. Again, the original variables plus the X underscore variables. And now this is just a little step that I added in for myself to make some fake identifying data sets. So what I'm doing in this step is just creating a data frame where, so if you receive some identifying information from your State Department of Health, you'll have the identifying variables. So maybe it's like, race, ethnicity, gender, age, HIV status, or I don't know, whatever your state releases. So you have those identifying variables, and then you'll have another column with either the sequence number or the PSU. So sequence number and PSU, those are like the respondent ID. So the primary sampling unit and the sequence number identify the individual. So what we want to do so I'm making some fake identifying data sets. So I'm making a data frame where I have one variable called sequence number, which actually contains the contents of the sequence number from our data files. All right, so I'm making a sequence number column, and then I'm making two identifying variables that I'm calling ID1 and ID2, and I'm just filling up those columns with zeros because it doesn't matter. I'm just using them as placeholders to, so that we can see what it looks like to merge the identifying data files with the original BRFSS data. All right, so this is just for me. I'm making some ID data sets. Okay, so I'll just read those in. And if we glimpse ID 2015, we have our three variables, so the sequence number, identifying variable 1 and 2. All right, let's do that over 2016 and 2017. All right, and I don't know how it works in other states, but so my university is in Indiana, so I had a contract with the Indiana State Department of Health, and they released the identifying data to me via an email that contained a link to another secure site where the identifying data set was available as a CSV download. So I got my identifying data as in a CSV file format. So I don't know how your state works, but assuming that they send you the data file, whatever you do to read it into R, right? So you should have either a sequence number or a PSU, and then the other identifying variables. So now I have my fake identifying data sets for California over 2015, 2016, and 2017. So what we want to do is merge our identifying data set with our actual data set by the kind of respondent ID variable. So in my case, I set that to sequence number. For you, it might be the X_PSU or _PSU, whatever. So that function is called merge. I want the identifying information to be at the beginning of the data file, and then I want my data file, and I'm going to merge it by equals the name of the variable wrapped in quotes. And I'll do that over 2015, 2016, and 2017. And I'm going to call these by the object names ID for identifying California 2015, ID California 2016, and ID California 2017. So copy those in. And if I glimpse ID California 2015, our first three variables now are sequence number, ID1, and ID2. And I believe if you scroll down and look for the original sequence number, it won't have a duplicate column because you merged it by this variable. So instead of adding three additional variables, it actually only adds the two identifying variables and then merges it on that sequence number. So we can confirm that, I guess. So variables, we have 408 variables now in the ID California 2015. If we just look at California 2015, we should have 406, right? Let's check. Yeah, 406. So I was correct. It did not duplicate the sequence number variable. It just merged on that variable and then added the two identifying variables. All right. So if you're working with identifying information that you received from your State Department of Health, that's how you do it. You just merge it on the you merge it on the variable that represents the respondent ID. So whether it's sequence number or the primary sampling unit. Now, if you wanted to bind multiple years of data together, what I would like to do is just do a row bind, R bind, over the three data sets. So when we try that, let's see, actually I wanted to call this LLCP 15, 16, 17X. So when we try to bind them all together, it doesn't work because, as you know, the variables are different between the years. So it says number of columns of arguments do not match. So if it had the same variables between all 3 years, even if they were not in the right order, then R would be able to match them up, right? It would sort out the variables and just bind the rows together. But because we have different variables between the 3 years, it can't even figure out which ones match because the number is different. So it's like we can't just simply R bind it. But if you selected your variables in advance across the 3 years and they were all the same, then you could probably just bind those rows together. But we're not doing that. What we have to do instead is we have to find the column names, so this function call names, that intersect between the 3 data files. So we have to create a vector of column names between the 3 data files, where the column names intersect. But this also won't work because for whatever reason, the intersect function can only handle 2 arguments. It can only look at the intersection between 2 sets of column names. It doesn't handle this third one, right? So unused argument, column names, ID California 2017. So to resolve that, what we will do instead is first find the intersection of the column names between 2015 and 2016, and we'll set that to an object called calls for columns 1516. So it can handle that, and then when we look at calls 1516, we see that these are the variables that intersected between the 2 data files. All right, so 250 something. All right, so now we've found the variables that intersect between 2015 and 2016. Now we want to bind together. Let me make that a little bigger. Okay, so we want to bind together these data files. We want to keep all the rows, so we don't put anything in the bracket for the row space, right? Then comma. We want to bind only on the columns that intersect. So that's calls 1516. So now we can row bind together these. Now we can row bind together these 2 data files on the columns that intersect. All right, so that function is rbind, ID California 2015. We want to keep all the rows, but keep the columns, only keep the columns that intersect. And we want to row bind that to 2016, keep all the rows, but only keep the columns that intersect. So let's run that. And then when we glimpse ID California 1516, we can see, all right, so now we have all 258 observations that intersected and almost 24,000 observations when we combine 2015 and 2016. All right, so this is 2015 and 2016. We also want to add 2017 into the mix. So we have to do that one more time. So let's set a new object name called calls 15, 16, 17, where we look for the intersection between the column names on this new data file that we just made. So ID California 1516. We want to intersect those column names with ID California 2017. So ID California 1516 is the data file we just made. It has 2015 and 2016 together. ID California 2017 is the data file that we still want to attach in. So let me run that. And when we look at calls 15, 16, 17, we see that these are all of the variables that intersect between the 1516 data set and the 2017 data set. And then again, we want to bind together the 15 1516 data set on the columns that intersect between all three, and then bind that to the 2017 data set according to the columns that intersect between all three. And then when we glimpse at IDCA 15, 16, 17, we can see that there were 231 variables that intersected between 2015, 2016, and 2017. And then across the three years of data, there were 33,352 observations. So yeah, now we have our data file, IDCA 15, 16, 17, which has the identifying information that you may receive from your State Department of Health, and we've combined all 3 years of data. All right, so I think, yeah, so that's that for combining multiple years of data and merging in your identifying data set. I just wanted to review, in case you forgot, that this notation with the brackets, so this means that we are taking this data file and we are selecting certain observations. So those brackets means look in this data file and pull out, these rows and these columns. So as I said, we wanted to keep all the rows, but we only wanted to keep these columns. So I talked about this in one of the early videos in this tutorial series, but in case this notation looks unfamiliar, that's just kind of a refresher, that the brackets indicate that we want to kind of subset that data file according to a select number of rows or a select number of columns. Okay, so yeah, we merged our years of data and we also attached our identifying information. So what we're going to do next is set some reference levels and reorder factor levels. So I'm going to end the video here and then pick up in just a second. So I'll see you back here really soon. Bye.